Welcome to Summarized Science, where we break down complex discoveries into bite-sized pieces. Today, we are looking at the mystery of the missing neighbors right in our own celestial backyard. Astronomers have long known that our Milky Way is surrounded by smaller satellite galaxies, but theory says there should be way more than we can see. This paper explores the hunt for ultra-faint satellites that have been hiding in plain sight. The researchers used the highest resolution simulations ever performed to track how these tiny galaxies form and survive. A major part of the puzzle is dark matter, the invisible glue that holds the universe together. In the past, scientists worried that many small galaxies were destroyed by the massive gravity of the Milky Way. However, this study shows that the centers of these small galaxies are surprisingly tough because of their dense dark matter cores. Even when their outer layers are stripped away by gravity, these cores act like a protective shield. By tracking these orphan galaxies that simulation programs might otherwise lose, the team gained a more complete picture. The results show that there are likely hundreds of these ultra-faint dwarfs waiting to be discovered. Interestingly, some objects discovered recently might actually be these missing galaxies, rather than just clusters of stars. These objects are called ultra-faint compact satellites, and they sit right on the edge between a galaxy and a star cluster. The paper suggests that these systems are dominated by dark matter, which gives them their unique properties. These tiny neighbors have survived for billions of years because they reside in the densest parts of their dark matter halos. One fascinating result is that these galaxies tend to avoid the very inner regions of the Milky Way. This explains why they have been so difficult to spot, as they are mostly scattered far out in space. The researchers predict that upcoming surveys will find many more of these systems in the Southern Hemisphere. This work also confirms that the hydrogen cooling threshold is a key rule for how galaxies are born. Basically, if a dark matter clump isn't big enough to cool down gas, a galaxy will not form inside it. This sets a natural limit on how many small neighbors a galaxy like ours can have. So, what does this mean for the future? To recap, the important point is that there are likely twice as many ultra-faint dwarfs out there as we currently know about. These missing worlds are predicted to be incredibly dense and heavily influenced by dark matter. Proving these findings would provide massive support for our current understanding of how dark matter clusters together. It also shows that our galaxy is much more crowded than the night sky leads us to believe. Future telescopes like the Rubin Observatory will be the final test for this theory. If they find these missing satellites, it will change how we view the evolution of the Milky Way. This journey into the invisible reminds us that there is still so much to learn about our own home in space. Thank you for watching Summarized Science.